Start. Mm-hmm. 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 Okay, this is the probability. Each document has their own theta of d, and then all probabilistic graphical model in figure 1. Beta is for the topic, alpha is for the theta. Assume to be sampled once. In the process of generating a corpus, the variables are document well variables sampled once from ZDN, assignment, WDN, la 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 la. Okay, it is important to distinguish LDA from a simple Dirichlet multinomial clustering model. What is that? A classical clustering model would involve a two-level model. Oh, maybe that's what we are looking for. In which a Dirichlet is sampled once for a corpus. This is actually what we are looking for. A multinomial clustering variable is selected once for each document in the corpus, and a set of words are selected for the document conditional on the cluster variable. Where is that model? Where can I study that? I want to study that. As with many clustering models, such a model restricts a document to be associated with a single topic. LDA, on the other hand, involves three levels. We have our user has one type, so we want to have that to being associated with a single topic. LDA, on the other hand, involves three levels, and notably the topic node is sampled repeatedly within the document. So, okay, maybe we don't need to go inside the mechanism of LDA anymore. That's perfect. Under this model, I wanted to read this whole shit. No, I don't need. Model document can be associated with multiple topics. Alright, now let's see if, what is this? Is there any work done on this? Na, 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 na. La 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 simple Dirichlet. Na 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 na. Mm. Mm. Well, okay, even this model is not exactly our model because our model is cascade, and also, even if you're of type 1, you still have odds of choosing from the other type. So it's something in between. Well, we already read about it. Oh, okay, section 1 or 2. Okay, let's search this one. Mixture opinion from. How do you estimate the parameters of this model? So our model is not exactly this model too, because our users still can click on topics on the other categories. Mm. All right, now we can. Okay, it is kind of equivalent. We can say um, we have like two distributions over all the clicks, and instead of looking, well, that's true. That's always the case. We have it is our model actually, very similar, much more similar. Because once you are assigned, like even in our model, we are saying, okay, the relevance score of this item is 0.1 for an item that doesn't belong to the user's type. Uh, so it is our model. Okay, so mixture of unigrams. Let's search that. Let's go to Google Scholars. Okay, it seems it is already in this paper, alright. I remember the code that estimates the topic cluster based on the so okay, I think we can stay in the same paper and they go over a mixture of unigrams. Why does it take so long? Don't look at your phone. I need to explain. Smoky. Thesis. What was that? The other name they gave? Dirichlet Martineau. What is K? Case 2. Okay. Sounds good. Let's try it. I don't want to try. No commas. No commas. I don't want no dramas. Woo! Okay. This is not the documents. Yeah. Instead of documents, I should name it what? Positions clicked. Now, look, I'm learning machine learning, clustering. That's why I love ChatGPT. Alright, where is it? Where we generate, okay. Positions clicked, and then once we wanna take it to LDA, okay, input data is positions clicked in LDA. Click list is positions clicked. I don't want to hear about no dramas. Then here positions clicked, and then here clicks list is position. And then positions clicked is input data for LDA. So I think we can use the same documents and vectorizer and vocab. What did I do? Oh, okay. I think we have this stuff already. X is vectorizer that we transform documents to array. What is it called? Mixture of vinegar. Oh, okay, so X array. Alright, I think I can do it myself. I learn it. I wanna learn. So we need the dot to array. We need to have this X documents dot to array. So that's what the line I wanna learn. Are you still analyzing? Wait, what happened? Oh, okay. So let's compare them and learn. Alright, I think we need to just make it simpler for ourselves. No, no. Smoking marijuana. Okay, so we have our X, and I want to say here I just add, or actually here, as ChatGPT said, we need to turn it into dense vector. Why? I don't know. Dense array. Why we do that? I don't know. And then everywhere we need to change it X array. Okay. And then this is, what is K? Okay, K is 2. So everywhere we find X, we need to make it X array. Sorry. I could give it to ChatGPT too, by the way. Mm-hmm. What is Anna 9? Okay, I don't want to define Anna actually. Don't. It's just addiction. Wait, how do I look here? Okay. Green, blue, and white. Is there a country with green, blue, and white? Sierra Leone. That's beautiful. Um, I don't want to hear about no dramas. This is this part I don't want to do. This one I want to do. What? And it's not defined. Are you fucking kidding me? I think I deleted something. You don't have N here? What did I delete? Oh, N was defined here. didn't delete anything. Where is N? N is 9. Okay. Dude, it's 100 data points. What the fuck? Oh, I should have. Oh, actually, this is far worse. Alright, let's keep that in mind. I don't want to plot their results yet. But it was very fast, right? By the way, what thing they used? Maybe we don't need this actually. That's not the big part of it. 'That is crazy. Who said N6? And zero 356 0 3 5. Nope. 6. Not really, not a good result. What is our? But what is their theta? Mm-hmm. That's kind of different from our model too, because our model says users are with like probability P category 1 or category 2. So our model is kind of in between. Oh! Well, that's what we want. Not QDK, but actually, from an estimation point of view, it may not matter as much. Anyways, I think we can read the paper. crux of understanding how these models work. Crux. What does crux mean? Crux.
Crux.
Crux. Heart. Center. What is the number of documents? K number of documents. Just give me the Q. Where is it? Positions clicked. Parametric empirical based models. Well, so we can actually know where to look at if you want to get deeper in these models. So in section 5, we adopt empirical. Is invariant under the permutation, exactly. For each finite subset, it is. Finite representation theorem. I don't want to hear about no dramas. I don't want to hear about no. So you can see the effect of ranking is important. Yeah. Actually, this is worse than LDA. Okay. Mm-hmm. 0.7 was the number, right? Interesting. Alright, so the other model is not super promising. It seems ranking is important for us. So our model is based on the cascade. I think now honestly we need to just have another data set. Well then. I want to hear about no dramas. That's an interesting theorem. I don't get it. The finite representation theorem states that the joint distribution of an infinitely exchangeable sequence of random variables is as if their distributions are equal. As if a random parameter were drawn from some distribution, random parameter was drawn from, then the random variables in question were in the IID condition on that parameter. So exchangeability says if it is infinitely exchangeable, it means that you have an IID sequence of like they can be IID Gaussians, but their mu is generated by a random parameter. Oh shit! No. Symmetry is exchangeability with latent variables. Mixture models. Let's go through an example to make it concrete. There's a binary variable. Suppose we observe a long sequence of coin flips x1 to x, and their parameter is with what probability p they belong to. They are 0 or 1, right? Mm-hmm. Or you just assume exchangeable. Random variable theta such that given theta the Bernoulli in order. So it's not just their IID. We have more room. If theta is deterministic, it is a special case that they will be IIT. Weaker assumption than independence. Symmetric enough, that's beautiful. That's deep theorem. Now the act is like a sequence of the beta. Um, um, Sketch of the proof, deep and elegant. Finetti's representation theorem in the simplest case, binary valued variables. Mm-hmm. By exchangeability, we have this number of heads. Okay, but what about the continuous random variable? Use the moment when we define mu n of b. Mm-hmm. Well, it is significantly deeper than the binary case because we don't have this fucking sum. A bit more machinery, I'll give you a clean intuition structure. So in general, the Finetti theorem would be an infinitely exchangeable sequence of random Polish space. Ooh, what was Polish space? Dense and something like that. Oh, okay, I want to see that part. Alright. As in the discrete case, exchanger implies symmetry. The joint log is invariant under permutation. This distribution is determined by empirical measures. What is delta of xi? Empirical distribution of the sample. Ideal is joint distribution of the empirical. Is it their distribution? Oh, okay. Dude, I remember it is Huit Savage. I read that. Savage or whatever. Okay, we don't get deeper in it for now. In LDA, we assume this. Okay, that's interesting. Definitely was interesting. In LDA, we assume that words are generated by topics, by fixed conditional distributions. Yes. And that those topics are infinitely exchangeable within a document. Yeah, by definite theorem, the probability of a sequence of word and topics must therefore have the form. Yeah, given theta, they are independent. Okay, fuck that. You didn't need to say definite, bro. Theta is a random. You could say they're just random IID. That was too much, honestly. No. Now that's why we don't want to read papers, we want to read ChatGPT. Parameter of a multinomial, we obtain the LDH around marginalizing out the topic variable and then doing theta with a continuous mixture of unigrams. Oh, okay, it is the one that we were looking for. Guys, 5 minutes, alright. The LDA model shown in figure 1 is somewhat more elaborate, we know that, than the two-level models often studied in the classical hierarchical Bayesian literature, marginalizing over the hidden topic variable z. We can understand LDA as a two-level model. In particular, is it? LDA is two? First we choose theta every time, that's the difference. And that's the difference with LDA and the simpler ones, is that we choose theta every time. We define the following generative process. It's from the word distribution, probably word theta is over z, word given z beta, and probability of z given theta. This is a random quantity since it depends on theta. We now define the following generative process for a document approaches. Okay, this is just the generative process of it. There is lot of alpha for each of the n words. Wn. Choose a word Wn from probability of W given n. This process defines the marginal distribution document as a continuous mixture. Or mixture component. Figure 2 illustrates this interpretation of LDA. What is it? An example density on unigram distribution probability of W given theta and beta, their LDA. This is a density of a word given theta, okay, and beta. And, given theta, not Z, okay. So it is kind of mixture of these four components. And there are for 3 words and 4 topics, alright. What is the 3 words? The triangle embedded in the xy plane in the 2D simplex representing all possible multinomial distribution over the 3 words. Oh, size of the vocabulary, alright. Each of the vertices of the triangle corresponds to a deterministic distribution that is probably 1 to 1. Okay, those are actually our topics, alright. H gives probability to 1, and the centroid of the triangle is uniform over all 3. The 4 points marked with an X are the location of multinomial distribution with W given Z. For topics, and exactly they are the topics. And the surface shown on top of the simplex is an example of density over V minus given by LDA. Which is in this one particular instance of an LDA method. That this is this one. Relationship with other latent variable models. Alright, this is maybe unigram model. Perfect. Woo, woo, woo. Oh, I'm so tired, guys. Water. Relationship with other latent variable models. In this section, we compute LDA to simpler latent variable models for text, the unigram model, a mixture of unigrams. So we have unigram and a mixture of unigram. And the PLSI. What was PLSI? LSI. PLSI. PLSI. Sounds like PLSI sounds like what? Ah! What is it? PLSI sounds like something. ENSI, BNSI, VNSI. ASMR, no. VNSR, no. PLSI. Dude, I don't know. PLSI. Fuck it. PNSR. ESNR. SNR, no. ELSI, no. Alright, under the union, the words of every document are drawn independently from a single multinomial distribution. Property of the word depends pi of property of word, and this illustrated the graphical model in figure 3a. What is it? So the unigram model is just bullshit. There's only one topic. 3a is we have word, we have n words, and we have m. What was m? Documents. Yes. Then we have z that says, what is the mixture of unigrams? The z says, alright, this topic belongs to this topic. Words are generated. And then we have PLSI. I don't remember. Aspect model that gives D and then Z and then W. Mixture of unigrams. It says it's just a mixture of them. That's why Coke is so good. If we augment the unigram model with a discrete random variable Z, 3b, we obtain a mixture of unigram models, NIGM. Under this mixture model, each document is generated by choosing a topic Z and then generating n words independently from the conditional multinomial PW given Z. The document is this. So there is no topics. There is only one topic. When simulated from a corpus, the word distribution can be viewed as a representation of topics under this. Each document exhibits exactly one topic as name. So we also know where to read this motherfucker, Nigam et al. And when estimated from a corpus, the word distributions can be viewed as a representation of topics under this. Exhibit exactly one topic, as the empirical results in section 7 illustrate this assumption is often too limiting to effectively model a large collection of, alright, it's not flexible, alright, but for our data probably works. In contrast, however, in Our data actually. Um, in our data, let's go. Then the LD, okay, in our data, LD actually did better than mixture of unique. MIU, MOU, MOU. In contrast, allows you to examine multiple topics to different degrees. This is achieved at the cost of just one additional parameter. Well, every time you are generating a data, you're updating your alpha. Probabilistic latent semantic indexing, PLSI, VNSI, CNSI, GNSI, MNSI, PLSI, PLSI, CNSI. I don't know! Probabilistic latent semantic indexing is another widely used document model, Hoffman 1999. The PLSI. The PLSI model illustrated in figure 3C. Okay, you generate D first and then Z. Posits that the document labeled D and a word WN are conditionally independent given an observed topic. What does that mean? I didn't get it. Probability of D and word WN input. Probability of D and word from that fucking topic. That attempts to relax the simplifying assumption made in the mixture of unit that each document is generated from only one topic. Well, this is what we want to generate. In a sense, it does capture the possibility that a document may contain multiple topics. Serves as a mixture weight of the topics for a particular document. However, it is important to note that D is a dummy index into the list of documents in the training set. Thus, D is a multinomial random variable with possible values as there are training documents, and the model learns the topic mixture POC only for those documents which it is trained for. This is not a well-defined generative model of documents. Okay, it's not a well-defined generative model. That's great. There is no natural way to use it to assign power to a previously unseen document. Okay, fuck PLSI. Fuck PLSI. I couldn't say what sounds like PLSI too. Alright, fuck it. I'm not gonna go this edit. Where it comes out of this problem by creating the topic mixture to keep on. And the writer the large set of integer which are explicitly included training says described. LDA is well-defined generative model. I agree. The new document, the capability. So we just don't need the generative part. Yeah, at the end of the day, it's all about prediction. Okay. Geometric interpretation. That's beautiful too. What is it? Why am I like this? Let's go. Dude, once you study the paper through ChatGPT, going through it is much easier. It is. The only thing with ChatGPT is that we cannot leave comment on each other's answers. So it sounds very solo, right? On internet, like you get your web page goes up, gets more value if other people like it or click on it. Here it's just you are alone with yourself. So how are they gonna generate more data over the times to feed their new machine? Are they going to use the previous data on the internet all the time? Now, because they have a lot of chats with us, they can learn, but those chats, because they are private and one-to-one, maybe they are not solid information, so that like there is a collective agreement that this answer is right or wrong. Okay, I think it's good. By considering geometry of the latent space, yeah. Mm, I know. Mm. Well, I think it was far better if you used 4 words. Yeah, we should name this video the use of N word in science. Okay, now it's the interesting part. We didn't care about the generative part. We care about the estimation part. Oh, why is it on heat? Mm, Oh, dude, I'm tired. I am not tired. Fuck tired. I'm not tired. There is no food at home, by the way, so even if I pause it. Oh, I can go eat some eggs. We have described the motivation behind LDA and we will see the section over the other. In this section, we turn our attention to consider foreign inference and parameters. So the most important thing in LDA in everything here is that they assume exchangeability and it kills our independence and it kills the effect of ranking. That's the main point. And we want to see if we can add the effect of ranking or into them how they work with ranking. So it is a major big added assumption in our model. In all of these models they say fuck the ranking. Instead of computing the search on a hidden variable given document theta and z given w is the document, alpha and beta we assume at the beginning. We want to find alpha, we want to find beta. Theta, once we have alpha we can have theta, once we have theta we can have z, once we have the z alpha beta w given alpha beta opportunity is intractable to compute in general. So in general speak, so we narrow it down to focus or only look at the Dirichlet family. Indeed, to normalize the distribution, we marginalize over the hidden variables and equation 3. Where is equation 3? How did I open a new one? Not like this. They not like us. From here. Where is equation 3? There is no equations. Okay, that's probability of document given alpha and beta, alright. Theta and beta are coupling. Oh, it was also studied in 1983. That's crazy. So, okay, but all these bullshits about exchangeability reduces to independence. In our case, it is not independent, but still, we just want to have a decay factor here. And probably it's somewhere here. Number of words. Okay, number of topics. And V is the size of the vocabulary. So what is missing is, well, we can keep the Dirichlet family. We don't have vocabulary effect. At each position, we just choose that word or not. So, all right, let's keep it there. Okay, they want to lower bound that likelihood, and they want to maximize. So what are they? They are trying to find the tightest lower band for the likelihood function. Then we want to maximize the likelihood. They say let's maximize the tightest lower band. So that main problem is not tractable. The main problem of this fucking likelihood we have there above is intractable. Instead, they find the tightest lower bound. That is decoupled probably, and that is tract. So LDA, it is not an estimate for that generative model. Like that's not the maximum likelihood estimator for that generative model of LDA. It's an estimation of likelihood that you're. Five. Okay, this is the alright. This is the graphical model of the LDA, how to generate data through LDA. Right, graphical model representation of the variational distribution used to approximate the posterior LDA. We have gammas, we have thetas, and we have phi that gives us z. So it sounds very, I don't know, what the fuck are these graphical models? What the fuck is a graphical model? I don't understand. It just tells me alpha produces theta, theta produces z, but to be honest, so gamma gives us theta. What is a graphical model? Let's ask ChatGPT. How edges are conditional or Bayesian Markov problem. Oh, okay. That's good. What are the rectangles? So I think it's just about like conditional distribution, and also it gives, I think rectangles are about, like here we don't have rectangle between gamma and theta, or z and w are no rectangle separating them. What are they? Alpha gives data about distribution of theta. Theta gives distribution of z. But z doesn't give anything about the distribution of w, it just makes w. Construction for Bayesian networks nodes, each node is a random variable, can be observed or hidden. There are unshaded nodes latent on. So which one is shaded, which one is not? W is shadeds are observed. Observed, unshaded, unobserved, latent in your figure. Edges, arrows conditional doing if there is A to B, then B depends on A, that is B given A. Plates. Oh, plates, alright, the rectangles. Rectangles represent replication over indices. What does that? N over words in a document, M over documents in a corpus. Oh, it has N over document. Okay. Mm-hmm. Probability of x1 is probability of xi given their parents. Perfect. Makes sense. But the graphical variational approximation, this is just two separate, it's not a connected graph. It's what do they disconnected. Um, so n folds times m folds, phi z and gamma theta. Q of theta and z, theta and z. Gamma is the variation of parameter for q theta. Um, Parameter for q theta, phi variational parameter for q of zn. Okay, just the graph. Q of theta, Q of zn. N-fold on. What about the n-fold? Theta given mean field approximation. We break it. Independent of each other. Theta is coming from gamma and z coming. Theta and all zn's are independent. Why? Evidence lower bound. Elbow is evidence lower bound. How is it elbow? It's elbow. So actually the generative model is just doesn't matter. We came up with a story and then we said we want to estimate this generative model, but now from it is a mental masturbation, but works this time. We assumed something, came up with a model, a likelihood, and said then we cannot estimate this likelihood. Let's simplify it and give a tight lower bound. What is it called? Estimate evidence lower bound. So you started with some model. It was too complicated. We simplified it and then we assumed. Interesting. We can do that too. We came up with the cascade model. We said, fuck this is too complicated to estimate. That's what we want to do actually. And we probably want to find a simpler model to estimate the cascade. However, even our real data is not even neither generated by the LDA or generated by the cascade. Interesting ideas. It's like engineering shit. Theta and beta. Let me look at theta and beta another time. Theta and beta. Well, of course they should couple, so to make W. Endowing. Endowing or endow? Gamma and phi. Q of theta given gamma. But I wanna get to the confidence lower bound. That's the part that will be interesting. I want to know how they separated this and estimate lower bound. Works fine, probably. Evidence lower bound. BO bound, BO. Guys, let me see if I can find something to eat. Guys, I have to go, but PLSI, DSLR, I found it.